Hey, physical science, it's Monday, May 4th. Do you have the periodic table that I attached to your assignment today? There's the front, there's the back. If you don't have that, go ahead and print it out now and then, pause this thing. Do you have your textbook? Of course you do, because you always have your textbook. Open it up to the back cover. Go ahead and pause this thing if you need to and get those two things together. If you don't have a printer, at least bring me your textbook. You should have that at every session, of course. And you probably your pencil, your paper, and your calculator. Okay, we're back. We've got this periodic table that I've doctored up. In fact, some kids go to college and say, Mr. Schultz, would you go ahead and fax that thing to me? Or would you go ahead and scan it and send it to me as a document? Because this is so valuable for them when they get into college chemistry. And you can see that I've doctored it up at the top. I put a 1 there. I circled the 1 and put a +1. Circled the 2, put a +2. Over here on the aluminum group, I circled the 3. In other words, I made it from a 13 into a 3, and I put +3. I skipped group 4 because they're fence sitters. They can't make up their mind if they're going to lose electrons or if they're going to gain electrons. This group 4 is right in the middle. All right, and then we've got group 5. It says group 15, but go ahead and circle the 5. And that's what I've done. And then put -3 above it. And then this group here is group 6 or 16. Used to call it 6A when I was a kid. And then -2. And then right there is group 7 or 17. Call it what you want. And it's it's -1 when it forms an ion. And then this group here is group 18 or 8. It has 8 electrons in the outer energy level, and it has no combining capacity. It has a 0 charge. It does not form ions. It does not combine with other elements. These are the noble gases. They are stable already. These atoms here are unstable, but when they form ions, they become stable, but they have a charge. And so then they combine. The positives over here, that's the metals, combine with the negatives, which are the nonmetals. The metal-nonmetal bond is called an ionic bond. Okay, so we're going to go ahead, and by the way, the metals are the losers. Do you see that? Losers of what? Losers of electrons. The nonmetals are the gainers. Gainers of what? Electrons. And so over here, what did I write? Oh, all the metals except hydrogen is not a metal. And some periodic tables, you'll see them put hydrogen right in the middle because it can't make up its mind whether it wants to act like a metal or a non-metal. Okay, and then the non-metals I've written over here. So we're going to go ahead and do that to our book. Watch me. I want you to write in your book. Not a problem. This is a good deal. You get to write in your book today. So here we go. We're going to go, this is group 1. It has 1 dangling electron in the outer energy level. We're going to put a +1 up here. That means it becomes +1 when it ionizes. Okay, this is group 2. It becomes +2. This is group 3. Oh, we're going to skip all the transition elements. Say that, transition metals, transition elements, transition metals. We're going to skip groups 3 through 12 for right now. All right, and then group 13, we're going to call that group 3. Just going to kind of scribble off the 1. And this is group 4. We're going to call this group 5, group 6, and group 7, and group 8. We're just going to scribble, subtract 10 from all those. Okay, and when group 3 forms an ion, it loses 3 electrons and becomes +3. So put a +3 above it. Which is easier? And by the way, put losers over here by the metals and write the word metals at the top, except hydrogen. And over here are the non-metals, put non-metals over there. and put gainers. And so we're going to go ahead and finish this up. Group 4, we're not going to put anything there. Group 5, we're going to put a -3. Group 6, -2. Group 7, we're going to put -1. And we're not going to put anything here on the carbon group. Okay, and then on the oxidation number, let's call them oxidation numbers, okay? Combining capacity, ionic charge, call it what you want. We've got a 0 here for the noble gases. Now, here's the question. Do you see oxygen? Now, oxygen has 8 total electrons. 2 of them are on the first energy level, leaving me 6. See the 6 right there? 6 for the second energy level. That's the outermost energy level for oxygen. It only has 2 energy levels. Let's go over here. Yep. Second energy level. Yep. And go above oxygen has 2 electrons. Well, then what about the one right below it? Sulfur. Well, sulfur has first energy level has 2, second energy level has 8, so they're full. And the third energy level, see that 3 right there? Period, stands for the period. Come over here to sulfur and go straight above sulfur, and it's got 6 electrons in the outer energy level. And oxygen has 6 also. And selenium has 6 also. They all have 6, except that selenium has 4 energy levels. And those 6 are on the 4th energy level. Okay, now, which is easier for oxygen? To become like a noble gas on the electrons on the outer energy level. Would it be easier for oxygen to lose 6? What's 8 minus 6? 2. And become like helium on the outside? Or would it be easier for oxygen just to gain 2? What's 8 plus 2? 10. And become like neon on the outside. When it becomes like a noble gas, the electrons on the outside, and when it becomes like a noble gas and has a full outer energy level, it has become stable. And that's what it wants to do. It wants to achieve stability, which is called the lowest potential energy, but you don't need to know that. Anyway, and it forms, when it does that, when it gains 2 electrons, it forms a -2 ion, and that's what that -2 is there for. These are gainers. You see the word gainers that I wrote up there? These are nonmetals. These are gainers of electrons. And when it gains 2, taking that 6 on the outer energy level to an 8, which makes it stable, makes it like neon on the outside. When it gains 2, it takes a charge of -2. Well, how can you gain things and become more negative? Well, it's because you're gaining negative stuff called electrons. From where? From free space or from an atom nearby. These are basically vacuum cleaners. And they go like this. And they suck in electrons. They'll steal electrons from kittens. You know what I mean? All right. Nitrogen and phosphorus. How many electrons do they steal? They gain 3. What's their charge? -3. Where are those 5 electrons for phosphorus? Well, those 5 electrons are on the 3rd energy level. But the 3rd energy level could have 8 if it sucked in 3 more electrons. And when it does, it gains -3. It doesn't pull in 2 electrons. Phosphorus doesn't pull in 1. It pulls in 3 because it wants to become stable. When it pulls in 3, it had 15 electrons. It now has 18. It becomes like argon. So it has 18 electrons and 15 protons. What is positive 15 minus 18? Isn't it -3? So it's got an excess of 3 electrons. So that's why it's called -3 ion. Now, if you want to write one more word over here, these negative ions are called anions. A-N-I-O-N. An anion is a negative ion. See how that becomes an acronym? A negative ion, an anion. Okay, what are these positive ions over here then? The +1, the +2, and the +3. Those are called cations. So a cation is a positive ion. What's an ion? It's a charged particle. How does it become charged? A neutral atom gains electrons, if it's a metal, or it loses electrons, loses electrons if it's a metal, or gains electrons if it's a non-metal. That's called transferring electrons from one atom to another. Transferring away from metals and transferring into non-metals, the losers and the gainers. The cations are formed, +1, +2, +3, or the anions are formed, -3, -2, -1. And then the group 14 or group 4 doesn't have a charge. It doesn't know what to do. It can't make up its mind. So which is easier for oxygen? Is it easier to lose 6 electrons and eliminate the second energy level and become like helium? Or is it easier to just gain 2? Well, it's easier to just gain 2. And that's why the non-metals are gainers. Which is easier for a metal? If calcium, right here, has 2 electrons, dangling electrons I call them, on its fourth energy level, is it easier for it to gain 6 electrons and become like xenon on the outside? Did I get that right? Hang on, calcium. No, krypton on the outside? Well, it's kind of an oddball. Let's go to magnesium. Is it easier for it to, see it has 2 electrons on the third energy level. Is it easier for it to gain 6 and become like argon on the outside so it's stable? Or is it easier just to lose 2? It's easier to lose 2. And you remember those atomic models, those 2 dangling electrons are easy pickings for any form of energy surge that happens to fly by. So now do you have yourself a periodic table that is appropriately doctored up? Good. Now you're ready to make compounds, to write formulas, that kind of thing. All right. So we're on page 558. Can you see a guy with a goiter? The guy with the goiter, it's around his neck right here. It's because the thyroid gland has enlarged. And it enlarges because of a lack of iodine. And if you take a look at iodized sea salt, well, they put iodine in our salt that we use because we use it for everything. How can you have French fries without salt on it? And when you eat your salt, you are getting the iodine. Now, in third world countries, they don't have that iodine. I mean, they don't have the salt like we do packaged. And so they get the goiters there because we're more, you might say, advanced. We don't have that problem as much in America. So an ion is a charged particle that has either more or fewer electrons than it does protons. It's a cation if it loses electrons and has more protons than electrons. And how do you remember cations for positive ions? How do you remember that? It's because if you have a cat, you love your cat, right? And so you're positive on cats. Cation. Cats form ions that are positive. Okay. Cations are positive, anions are negative on page 558 in the middle, in the italicized word. When an atom gains electrons, it becomes negatively charged. It has more electrons than it has protons, therefore it has a negative charge, and it's an anion. I call it a negative ion. Now, what do opposites do? Do they attract? Opposites attract. And that's called a transfer of electrons, page 559. I'm going to stop there and pick up there tomorrow. See ya.